Hello everyone. In this lesson, we'll be discussing what is precipitation, the different forms of precipitation, and the different types of precipitation. I am Bhumika Saini. I have done my engineering from NIT Jaipur. You can follow me on Unacademy by following this link. Unacademy courses are free of cost, but if you like the course, you can pay an optional fee by following the contribute link on the Unacademy website. Now, what is precipitation? Precipitation is any form of liquid or solid water particles. Remember, it is liquid or solid water particles that fall from the atmosphere and reach the surface of Earth. Now, it may be in the form of drizzle, it may be in the form of rainfall, hailstones, snow, and sleet. So, it may be snow, sleet, hail, rainfall, right? So, we'll discuss about each in detail. Now, what are the necessary conditions for precipitation, right? First of all, either there should be evaporation, right? Then gradually the warm air rises, it cools, right? As it rises, it cools, and then after cooling of air, condensation and cloud formation takes place, right? We have already discussed about the different types of cloud and cloud formation in another lesson on clouds, right? Then after the cloud formation, accumulation of moisture in the clouds take place, right? And once the growth of the water droplets in the cloud increases to a significant size, then the water droplets starts falling or the precipitation starts taking place. Now, this may be in the form of rainfall or snowfall, hail, sleet, etc. Right? So, these are the necessary conditions for precipitation. Now, this water droplets and ice crystals of clouds, they are transformed into heavier particles, right? If they are to fall out of clouds as precipitation, right? Now, water droplets and ice crystal can only fall to the earth's surface if they grow to a sufficiently large size. That's what I told you. If they are of sufficiently large size, then only they will fall, right? And once they become of sufficiently large size, then only they overcome updrafts and they fall. So it may be in the form of drizzle if the water droplet is about 0.2 mm. It may be in the form of light rain if it is about 0.5 mm. Small rain if it is about 1 mm. Rain if it is about 5 mm. And rainstorm if it is about 7 mm. Okay, so this is the size. Okay, now what are the types of or forms of precipitation? So it may be in the form of rainfall, hailstones, sleet, snow. Now let's study them in detail. Now, in case of rainfall, liquid deposits falling from the atmosphere to surface with a diameter of greater than 0.5, right? It should be greater than 0.5. If it is less than 0.5 mm, it is drizzle, right? And maximum size is between 5 to 7 mm, right? Because beyond this size, the intermolecular cohesive forces become too weak to be held in the mass of water together as a single drop. So it is between 5 to 7 mm. Below 0.5 mm, it is drizzle. Greater than 0.5 mm, it will be rainfall. Now let's discuss the other form of precipitation, that is sleet or ice pellets. Now these are transparent or translucent spheres of frozen water. Here the diameter is greater than 5 mm. Remember, the size is greater than 5 mm. First of all, it develops as raindrops only, right, in a relatively warm atmosphere. So here the temperature is greater than freezing point. But if these raindrops, they encounter a colder layer of atmosphere which is less than 0 degree or which is less than freezing point, then it turns into ice pellets while reaching the ground surface. Okay, so here generally temperature inversion phenomena is there. Okay. Now the third one, that is snow. Now this particular snowfall, it takes place generally in middle and high latitudes, right? And it develops when the water vapor deposits itself directly in a hexagonal nuclear shape as a solid crystal. But here the temperature is below freezing point. So you can see here throughout the atmosphere, the air temperature is below freezing point. That is why these are formed in middle and high latitudes. And here the snow is reaching on the ground. Okay. Now the last one, that is hailstones. Now hailstones, these are generally found in thunderstorms, right? A frozen form of precipitation with a diameter of 5 mm, right? Here concentric shells of ice with alternating white cloudy appearance are formed, and they generally develop when the liquid water freezes onto hailstorm. Now how this happens? Generally whenever there is updraft, right, and the liquid water, it is falling down, right? So these hails, they grow in circulating currents, right, and gradually they increase in size and then they fall as hailstones. Now, the kinds of precipitation. There are three kinds of precipitation. One is convectional rainfall, the other one is orographic rainfall, and the third one is cyclonic rainfall. So let's discuss each in detail. So the first one is orographic rainfall, right? Orographic precipitation, it results when warm, moist air is forced to ascend by large mountains, right? Orography as such means mountain only, right? So here you can see this warm moist air is forced to ascend because this mountain acts as barrier, right? Now once this warm moist air it rises, it cools and it condenses. So here cloud formation is taking place, right? This warm moist air it cools and condenses, this cloud formation takes place, and on the windward side, this is the windward side, or you can also call it rainward side. This windward side, here all the precipitation takes place, right? It may be in the form of rainfall or in form of snow, right? Now after shedding all the moisture here, the winds go on the leeward side. This is the leeward side or rain shadow area. So here generally there is dry air. So as the air cools, the water vapor in the air condenses and it forms clouds, right? So after cloud, precipitation takes place on the windward side, right? Now the air is dry and it rises over the top of mountain. You can see in the diagram, right? And then this dry air, this particular side of mountain is the leeward side and it receives very little precipitation. So this is the diagram of orographic rainfall. Okay, now the next one is convectional precipitation. Now this particular precipitation results from heating of earth's surface, right? So the warm ground heats the air over it, and as the air is heated, the air becomes light, right? And it rises. So the air molecules begin to move further apart as the air warms. With increased distance between the molecules are less densely packed, right? Thus the air becomes lighter, and once it becomes lighter, it rises rapidly into the atmosphere, and as the air rises, it gradually cools, right? And after cooling, this water vapor it condenses into clouds, and then precipitation takes place. So you can see it here. First of all, this is the air next to the ground surface, right? Here the sun rises by midday, then sun heats up the ground, right? Then air next to the ground, it is heated. Then gradually the moisture or the water vapor, water evaporates, right? Then the warm air, it rises, right? So this is the warm moist air which is rising. Gradually it is cooling and condensation takes place, right? After this condensation, the clouds are formed, right? And gradually after this, precipitation will take place, right? So there is heavy rainfall. Now in this generally in the convectional rainfall, these cumulonimbus clouds are formed, especially in the equatorial regions. This we have already done in the types of clouds lessons, right? So in this particular case, clouds like nimbus clouds, or generally this cumulonimbus clouds with great vertical extent will form, okay? And such rainfall takes place in equatorial regions, right? Now the cyclonic precipitation. Now cyclonic or frontal precipitation results when the warm moist air mass it meets a cool dry air mass, right? So as such, a warm front when it meets the cold front, then such cyclonic precipitation take place, right? So the molecules in the cold air here they are more tightly packed, that is they are more dense, right? So the cold air is heavier than the warm air. Now warmer air being lighter, it is forced up over the cold air, right? And as it rises, again the warm air cools, then after cooling it condenses, and then cloud formation takes place, and then finally precipitation takes place, right? So you can see it here. This one is the cold front, this one is the warm front, right? So the cold air, this cold front here, this cold air mass is active. This one is the cold air mass, this one is the warm air mass, right? So the warm air is forced to ascend, right? The warm air is forced to ascend vertically, and here cumulonimbus clouds with great vertical extent will form, and it will lead to precipitation, heavy precipitation with thunder and lightning. Now here where the warm air mass is more active, gradually the warm air mass will ascend, right? Here drizzle and rainfall will take place. Here intense rainfall with thunder and lightning will take place, right? We'll discuss this in detail in the cyclones lesson also, right? Thank you.